Hey, what's up, y'all? This is Coach O Daily coming at you from my house. I'm just basically on a break right now from burping my babes. I just want to give a shout out real quick to all my followers. I wouldn't be where I'm at without y'all. I'm just coming at you live, ready to do some math on the reel. We're gonna look at a paper that's green. For whatever reason on my video here, this is looking like kind of like a grayish white color. Just don't believe your eyes, all right? So this is a green paper. On the other side, there's just one little example. We're going to focus on an example that y'all might have seen before um, on some previous work we were doing. I just think it's a real good like example of like what we're doing here. So if you were to see pictures, right, we can call these steps. So this represents a pattern or a sequence, right? The first thing you're always going to do is you're going to label these steps. So each picture represents a different step in this pattern. I'm actually going to label, so the steps are going to be my x. Because what are they doing? They're changing, right? So I have x equals 1, x equals 2, and x equals 3. So what we want to find out is when x is on the fourth step, or so when x is 4 steps, what would that picture look like? So when I look at this, it might help you just to start by like counting the squares. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's 4 here. And then 3, 3, 3. Okay, so that's another, okay, so 13. So a lot of y'all would just be able to go 7, 10, 13, and kind of see that change as plus 3. So you know step 4 is 16, right? But what would it look like? So at step 1, you might want to kind of focus on like where are we, what's the change every time? So we're adding 3, right? Well, where are we adding the 3? Can you see where it's growing, right? So if you notice, those 4 tiles or squares are staying in the same place every time, right? And at step 1, you just have one little tile hanging off at the top, one on the right, and one here down on the bottom right, right? Whereas at step 2, you have 2, 2, and 2. But notice those 4 tiles stay the same. Here you have 4, but now we have 3 coming off, almost like arms, right? So if you were thinking about what would the fourth step look like, well, we have those 4 that we're going to start with, and then instead of having one arm or 2 or arms that are 3, those arms are going to be 4 for step 4. So we'll go 1, 2, 3, 4. So 1, 2, 3, 4. And then we're going to go 1, 2, 3, 4. And then we're going to go 1, 2, 3, 4. So here we have 7 at 1, 10 at 2, 13 at 3, 16 at 4. And so that could keep going, right? But what you notice is that there's always going to be that constant 4 that you're starting with, right? Your arithmetic sequence is just another way to represent this pattern. So instead of using just the pictures, we're going to pick out just the numbers. So the first number was 7, then we had a 10, we had a 13, and a 16. And then from there you could just put a dot, 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 which just means it goes on for ever. Describe the change from one step to the next. Well, from each time we moved steps, we just said add 3 for each step, or for every step you add 3 more. For a table, this would actually be pretty simple, right? So we have 1, 2, 3, 4, but we're going to see there's a slight difference on this one. There's a major jump. So at the 15th step, if this picture kept going forever, what would happen, right? So you could be that person who draws this out and tries to find at step 15 how many units there would be, or you can kind of focus on the start and the change. So we know that the change is add 3. right? And you can see it just with the numbers that we know. Well, where did this start? I don't see a 0 on the table, but if there was a step 0, right? So instead of adding 3, how could we find step 0? So instead of adding 3, we could take it away. So 7 take away 3 gives us 4. And what's really neat is, where did that 4 come from? Well, if you look at your picture, you can see the 4, right? We started with 4 blocks and then we added 3. We had our 4 and the 3 from here, but then we added 3 more, right? So every time it's growing on the ends, but that 4 stays the same, right? So if we know that the start is 4 and that the change is 3, you can basically set up an equation that would represent this change. So the step is going to be our x, and then the units depend on what step you have, right? So if you have lots of steps, you'll have more units. So x and y. So we're going to say y equals, this is kind of like those equations we do with the pizza. So our change is, we're adding 3 every time. So 3 depends on the x, right? So the steps is the x. So we're going to say y equals 3 times x, right? So for every step you add 3 more. So add 3, add 3, add 3, add 3. But then we had to start with those 4. So we're just going to start with those 4 by adding them to the 3 that we add every time. So we're starting with 4, and then we are adding 3, 3, 3, depending on the number of steps. Okay? So if you had 15 steps, right, you could say y equals 3 times how many steps? 15 plus 4. So what is 3 times 15? 45. And then remember, we had those 4 tiles that we started with, right? So 45 plus 4 is going to give us y. That means that at step 15 there would be 49 different tiles or units. Okay? So every time you do these types of patterns, you'll see some version of take the number of steps. Based on the number of steps, there's a change. And then you add in whatever you're starting with. Okay? And actually, this equation will be something that you guys see as you move into 7th and 8th grade math. It's called a linear equation, which just means it makes a line. And a linear equation usually has 2 parts. So the first part is we're changing the x, right? And then you're starting with some number that's not 0. So you're adding in that start. Okay, so we have a change which affects the x, and then we add in a start, right? So you could add in a positive or a negative, it just kind of depends. But based on these examples, I want you guys to finish this one, so see if you can find the start and the change. And then this one, which is a little bit weirder, but I'll post an answer key for this, so just if you want to check, you can, but I think you guys can figure it out. And then from here, your goal is to try to figure these out. And some of them are weird, right? It's kind of up to you how you see it. But generally, like on this one, if you see like on the back, you can count that square or you can not count it. It's kind of up to you. So like some people would look at this and say 1, 2, 3, 4, 5 shapes and then count the shapes here. But the idea is, where are the pictures growing, right? I will post a key on this. I might even make a little video for it as well. But your goal is just to figure out how could you build equations to represent these situations that would then help you make a prediction for any number of steps. Cool. I hope you guys have fun with this. I like it. It's like one of those things where everybody sees it differently, but it's just patterns and it's fun. So we'll catch you later. Bye.